Sathyabama Institute of Science and Technology.
Good morning. Today I am going to say about this specification-based testing. Specification-based testing is also called as a requirement-based testing, where we are going to test the software which is going to be developed. In this specification-based testing, we have the Equivalence class, which we'll be seeing for today's session alone. What is this Equivalence class? What is the advantage of using this Equivalence class in a specification-based testing? Suppose a customer asks me to develop a software for using 10 requirements, and I want to check all those 10 requirements with respect to the test cases. So for giving a input case for my requirements, I want to have this equivalence class testing. This equivalence class testing is a black box testing where it is going to use the based on the specifications, where it is going to have the independent of implementation. It never worries about whatever the language you are going to use. It is going to deal only with the testing cases, how the functionality is going to work, and it focuses on functional testing, behavior, input and corresponding outputs, which is going to be. Under the specification testing, we have the classification of this equivalence class. The equivalence class testing tests or provides the input for the test cases. What type of input, what type of output we are going to provide, and how we are going to give the inputs is going to be decided by your equivalence class testing. This equivalence class testing divides the inputs for the test cases with respect to the domains prefers mutually disjoint subset. The meaning of this is, right, it is going to give the inputs with respect to the outputs and how equal partition is going to be made for the inputs. That is, I don't want, suppose I have the numbers from 1 to 1000, right? It is not necessary for me to give the 1000 numbers as an input. Instead of that, I can group the classes into 5 classes. Suppose 5 classes is 20 number. Instead of giving all the 20 numbers, one number from each and every group. So the equivalence class is nothing but dividing the inputs into 20 units, or 5 units for 1000. So for one group, I will be giving only one value. So this equivalence inputs is going to be called as the equivalence class partition. The equivalence class, how useful? Instead of giving 1000 numbers, I told, right, I want to divide the group into 5. 5 in the sense, 1000 inputs, instead of giving 1000 inputs, right, I can give only 5 inputs and check the test cases. From every 5 groups, I will be giving only one element, I can test it. That is, it is not necessary for me to waste more amount of time on testing. I can divide the classes. That's the advantage of this equivalence class. It reduces the potential redundancy, that is, the subsets determined by the equivalence relation, the elements have something common, so they want to group it with respect to the equivalence class. The least amount of inputs can be provided for the test classes. What are the different types of equivalence class? We have weak normal, strong normal, weak robust and strong robust. These are the different types which are provided for my equivalence class testing. Which ensures to choose the correct set of test cases from the equivalence class. We come up with all these 4 types. What type of input? That is, how we are going to provide the input for the test cases. The first one is your weak normal. What does this weak normal say? For example, right, I have given a program takes 2 inputs x1 and x2. x1 and x2, where the x1 is going to be between A and D, the x2 is going to be between E and G. So we have the common intervals, or we take the intervals from A to D as a set for x1 and E to G as a set for x2. I am trying to define the classes for A to D. AB is a group, BC is a group, CD is a group. These are all subsets of A to D. Whereas EF is a group, FG is a group. These are all subsets of E to G. So from these groups, we are trying to provide the inputs. We are trying to provide the inputs and we are going to execute it. These are all subsets. A weak normal, one variable from each equivalence classes. A systematic way of deriving the equivalence class. How we are going to, what is this weak normal? If I give a set of groups, 4 different groups, right? From those groups, I am going to take one variable from the subdomains. Each and every group we call it as a subdomain of the entire domain. From those domains we are going to take one values. Here, weak normal. I have decided two values. Among these four values from A to D, another one value from E to G. E to G. So for what in this weak normal, right? I have taken three different classes. From each and every class, only one value I am trying to test. So F and G it's a subdomain, FE is a subdomain, CD is again a subdomain. From each and every subdomain, right, I am trying to take only one value from the set of group. So we call it as a weak normal. Next, we have a strong normal. What is this strong normal? From the equivalence classes, we are going to take more amount of values. Actually, we are taking the actual value from the subdomain. That is a positive value where the test case can work. That was the thing we are deciding. In your strong normal, right, we are going to take more amount of value which is going to be wrong. Some of the values which is going to be out of the box. The test select at least one test from each of the multi-dimensional subdomains. One value must be out of the domain, so that I am going to take each and every values and I am going to take about this strong normal. Instead of using one value, right, from each and every classes I am trying to take one values. One values and trying to check it out, it is going to be a strong normal. The thing is, suppose I want to test 1 to 10 as a value. Instead of taking, I want to make this 1 to 10 as a equivalence groups. So not 1 to 10, 1 to 1000. 1000 as a equivalence groups, right? 5 groups. From each and every 5 group, I am trying to take one value. Trying to take one value. Then we call it as a strong normal. Out of these 5 groups, if I take only 3 values, it is going to be a weak normal. A weak robust. What is this weak robust? It is a counterintuitive. Robust comes from the consideration of invalid values. In the first weak and the strong and the weak robust, right? In the weak robust, we are going to take the values which are going to be negative. They are going to be negative values. In the weak and strong, we are taking only the values which are going to be providing the output. Here, the weak refers to the single fault assumption. Your test case should have one invalid value and the remaining values should be valid. One dimensional invalid, that is, we are going to take some values out of the box and we are going to test. For a weak normal, for the equivalence classes, we have taken the actual values. Apart from the actual value, which is going to provide an actual value, we have provided an output, that is the output box out of the values. Box out of the values. It's about the weak robust. What is a strong robust? In the strong robust, the next one. In the strong robust, right, we have the values. More amount of values which is going to be out of the box will be considered over here. Strong robust, the multiple fault assumptions. Which I can write. Other than the actual values that I am going to provide for testing, I try to provide the invalid values and try to test. Invalid values and try to test. We call this as a strong robust. What are the equivalence class characteristics? A group forms a equivalence class if they all test the same thing. One thing is going to be, if they are going to test the same thing, then we are going to the equivalence class. If one test case catches a defect, the other probably will too. That is, I am going to give one value from the test case, one value from the equivalence class. If one value catches a error, then rest of the values will also catch the error. If one test case doesn't catch a defect, the others probably won't. If one value is not providing any error, right, probably the other values of the same group, the equivalence class will not be providing an error. What makes us consider them as equivalent? They involve the same input variable. If a group of value, the class that we are going to decides how the value is going to be. How the value is going to be. They result in similar operations in the program. From a group, it is going to work for one value. If it is giving output for one value, obviously it is going to give a output for the second values. They affect the same output variable. If one variable is going to infect or give an error for a particular value, obviously it is going to provide an error for the second values. None force the program to do error handling or all of them to do. If one is not giving an error, everything will not give an error. If one is providing an error, then rest of them is also going to provide a error. That's all about your equivalence class testing, about specification based. In the next video, we will be checking about equivalence class testing with respect to your boundary value analysis. Thank you.